Good evening. Welcome to the Biomass Conversion Biorefinery course. So today we again discussing the week 7 assignment with solution, as well as we'll see the some theory part of the week 8 which will be useful for you to solve the assignments. So no one is joined till now, but I hope so someone will join. And let's start. Today my health is a little bit I'm not feeling well, so better I can't able to talk much, but let's see how it will go. So I'm sharing my screen now. So please please confirm that it visible. Okay, no one is there, so yeah, it's visible. So I'm opening the presentation right now. So this is the presentation. Let's start discussing. So okay, so today we cover 2 week content, week 7 biodiesel and week 8 biochar and biooil. uh, he is a course facilitator, Professor Kaustubha Mohanty, professor from IIT Guwahati. Okay, so I again want to give my introduction. As a course team member, I am a Bhavik Kumar Mahan, Prime Minister Research Fellow, PhD scholar from Chemical Engineering Department in IIT Madras. So these are my mobile number and mail ID. If you have any uh, query, you can reach out to me directly regarding the assignment problems, regarding some query in this subject, or you need some guidance on the final exam. You can contact me. So last week we have seen the 7th week content, which is a biodiesel, and this week we are discussing about biochar as well as bio-oil. So biodiesel, we discussed that different kind of oils, vegetable oils, so edible and non-edible oils we are using, and we extract the oils and we go for the trans-esterification process, and at the end you will get the glycerol as well as biodiesel. So I will not go into the much each and every point detail for the last week discussion, but yeah, it's like this. So conventional non-renewable fossil-based fuel has taken research and development at energy. So biodiesel is one of the option. Why? Because it is a biodegradable, it is a non-toxic, renewable, and it's almost free of sulfur. So here you can see many kind of oil craft you can use: camelin oil, safflower oil, sunflower oil, rapeseed oil, castor oil, jatropha palm oil, and algae oil. So this is a kind of cycle of biodiesel. This oil crops, you will extract the oil out of it and from this the seeds of these vegetables, and you refine that crude oil, and then you convert it into you put it into you react it with the alcohol, and by using the trans-esterification process you will get the crude glycerol as well as biodiesel. Crude glycerol has many application in food, feed, cosmetics, and pharmaceuticals, and it's a very good solvent also. So whatever the biodiesel you will get, it will be used in the transportation sector, and whatever the CO2 which is emitted currently conventional transportation sector, the CO2 emission will be lower down by using the biodiesel. Now, so consumption of different vegetable oils in India. So actually in India agriculture we have various kind of vegetable oils, but due to they are using as a food in India, so we can't use them directly for producing the biodiesel. Unlike the other countries where they have few population, very less population, so they can use any kind of oil and convert it into the biodiesel. But we have some restrictions. Although if you want to see that what are the varieties of vegetable oils we are producing in India, and this is the figure. Highest amount is rapeseed oil, followed by the soybean oil, cotton oil, followed by the castor oil, and sunflower oil. And the other oils like sesame, palm oil, and coconut oil in some amount. So this is we can't focus on if we, in India we for the biodiesel. So which are the possible ways to use to produce a biodiesel? So there are other different kind of non-edible vegetables like vegetable in from which you are getting the oils that we can use like mahua, karanja, polanga, neem oil, rubble, and jethropa. And you see the jethropa life cycle from the okay. So we are discussing about the assignment problem for the 7th week, and then we move for the 8th week. So these are the part we cover, and we'll go through the problems. So these are the edible oils which we can't use for the production of the biodiesel oil, but at the same time we have mahua, karanja, polanga, neem, rubber, as well as jethropa. So you can use this kind of vegetables for converting into the oil. Now a little bit more information which we already covered into the last lectures. So there are different kind of fatty acids available into the vegetable oils, and major component is a triacylglycerol, which is known as a TAG or triglyceride, which TG. So out of it you can see this is a backbone of glycerol, and which the ester is attached with it. So if you can remove the one carbon chain, then it is a diglyceride, then eventually it converts into monoglyceride if you remove another one. So mainly if you talk about the saturated fatty acid, then there are three kind of fatty acids. One is a saturated fatty acid, where you will not find any double bond in the carbon chain, whereas another is unsaturated fatty acid of trans and cis. In the trans, the H atoms are what is connected into the double bond, they are the opposite sides, and the cis has the same size. Now what are the degree of saturation, unsaturation, molecular weights are there? So there was a question out of it. So mainly for finding the degree of saturation, unsaturation, or molecular weight, we are using the two different different concepts. One is the iodine value, another is saponification. So what is the iodine value? It is a number of grams of iodine that reacts with 100 grams of fats and oils. So if you can calculate how much amount of fats or oil is there, you can find how much unsaturation, saturation, and what is the molecular weight. This is the formula of iodine value. And another is the saponification value. So saponification value, a number, it represents how many number of milligrams of potassium hydroxide or sodium hydroxide are required. So we have the fatty acids inside and oils inside. So if we can react with the strong base, then it can be saponify the 1 gram of fat. So we have to find how many number of milligram of this KOH and NOH required for the saponify 1 gram of fat. And the question asked was the molecular weight of vegetable oils can be calculated by. So there are two options: iodine value, saponification value. We will not go to each and every detail. So here it is mentioned that iodine value, saponification value are used for the finding the unsaturation, unsaturation, as well as molecular weight of the vegetable oils. So answer is both A and B. Now if you talk about the compositions, then we have seen that every oil has saturated fatty acids or unsaturated fatty acid. So in saturated fatty acid, C16, 18, and all they are palmitic and stearic acid, same as unsaturated oleic, linoleic, and linolenic. So you can see C18 and then 1. So one is on double bond is present here, 2 double bond, 3 double bond, and you can see depending on the different oil, the values are different. So if you talk about the highest number of unsaturation, then it is there in the sunflower oil, and the lowest one is in the cottonseed oil. So this is the esterification process, where triglyceride has a 3, as we discussed, 3 carbon chain. It is reacted with the alcohol or 3-methanol in the presence of base medium and catalase. So it will convert into the glycerin as well as fatty acid methyl ester. So this fatty acid methyl ester is actually the biodiesel, and this is how this process is taken place. So vegetable oils directly or else waste vegetable oil by using the after performing the esterification process, we'll get the raw material. Then we have to go for this transesterification process. In that we require to add methanol, as well as for maintaining the base medium we are using the NaOH. And from this you will get two things: one is a crude glycerin and one other is a crude biodiesel. Crude means they have the unreacted part and impurities in it, so we have to refine it. So if you refine the glycerin, so out of it you will get the purified glycerin and methanol. The same in the crude biodiesel also, if the refining, you will get the biodiesel as well as methanol. So this is how this process works. And now we not go into the each and every detail, so we go to there are different kind of oils was explained by the professor. One is a soybean oil, so it is also referred as a glycine max. And if you talk about it is what is the origin, it is not clear, but it has a major gene center in Eastern Africa and Australia, and it has a oil content ranges from the 15 to 22%. And the major fatty acid are the oleic acid C18-1. So C18 is hydrogen carbon atom and one double bond is there. So question was asked in the assignments, if a fatty acid is represented by C18-1, then what does it indicate? So it indicates it has a 18 carbon atom as well as one double bond in it. At the same time, the major fatty acid is soybean oil, or which other fatty acid is in the major amount. So the answer is oleic acid as well as linoleic acid. So here you can see the major fatty acid are oleic acid, and which has C18-1. We can say 18 carbon atom, one double bond, and linoleic acid, which has two double bonds. So this is the answer: oleic and linoleic. Now after that, there was a rapeseed or mustard oil, canola oil, or the similar kind of species. So they all come from the Brassica family, and this has a oil content over 40%. So dominant fatty acid is oleic, linoleic, and erucic. So but the important time is erucic acid content is, if we high then 5%, it is called here or HER, high erucic acid, and rapeseed. And then if you are lower than less than 5%, then it is a low erucic acid rapeseed. So here, but you have to keep in mind that when you so first it is known as a different name and the different product. So canola oil is the same kind of family. If you extract the oil from the rapeseed or canola oil, then which has a low level of erucic acid and glucosinolate content. So the erucic acid is why important. If it is in acid, this acid content should not exceed 5%. So that is an important limitation if you want to go for the biodiesel production. So the question asked was, the erucic acid content in canola oil should not be exceed how much? So 5% was the answer. So my health is a little bit not good today, so pardon me. And another is the biofuel synthesis from algae by transesterification process. So same, we use oil, we can also use the algae. So here you can see that instead of oil we can use the algae. From algae we have to extract the oil, and we will get the two products. After from the oil we'll get the protein as well as biodiesel, and the biodiesel same has the glycerin product, as well as we can use it in transportation. So from the transportation, if we are using it, so whatever the carbon dioxide generated, we can use the carbon dioxide in the production of the algae, and it is make this like a close. So yeah, we don't have to for the transesterification technique, we have to go for the potassium hydroxide, sodium hydroxide, and sodium ethoxide kind of bases. So biodiesel in the presence of another catalyst like nickel and molybdenum, it reaches up to 100%. So in this transesterification process, more development is required in the field of catalyst. Now if you talk about the questions asked from this, then biofuel synthesis from algae by transesterification process. So as you can see here, if you talk about the microalgae, so in the particular which is from the green algae or diatoms, can accumulate significant quantity of natural lipids, which is nothing but the triacylglycerols or triglyceride. So for purifying it, and it has a lipid in it. So the question asked is lipid are generally soluble in what? So it is mentioned here that lipids are if we talk about the we have to purify this lipid, and we have to go for the significant conversion of the lipid content for the biofree production. Then the lipids are generally soluble in the non-polar solvent but insoluble in the polar solvents. So non-polar are the organic solvents which doesn't have polarity in it, while we talk about the water and all ionic solvents which has a polar nature. So that's why we can go for the non-polar solvents if you talk about the lipid solubility. So this is the answer. Now syngas biorefinery is also there. So in this, what is actually syngas? Syngas is a mixture of hydrogen as well as carbon monoxide. So nature gas called biomass can be converted into the syngas. How it is get converted we have already seen through in the previous lectures. So after it you can go for various ways to utilize this syngas or synthetic gas in the full form. So if you go for the methanol synthesis, from the methanol synthesis dimethyl ether you can generate can produce, and that can be converted into the various products, which is much more important in the as a petrochemicals. After this synthesis gas you can get the hydrogen and methane out of it. And if you go for the Fischer Tropsch synthesis, then after refining you will get the gases LPG, naphtha, kerosene, diesel, lubes and waxes. Now this transesterification process we already have seen that this is the backbone which will convert it into glycerin. Another part is converted into mixture of fatty acid, which is nothing but the biodiesel. So this is actually simplest reaction. And the question that was asked is the most commonly employed alkaline catalyst for transesterification reactions are. So we already discussed that many kind of catalysts are required because overall here we require the base medium in order to process this experiment. So mainly we know that sodium hydroxide and potassium hydroxide are strong base, so we can use it, and it is mentioned over here also. Conventional catalysts are the sodium hydroxide and potassium hydroxide. So we can use them in order to go for this process, and this is the answer. It is mentioned over here also, sodium potassium hydroxide. Now there was one concept of tuning. So I didn't go through the last time we had discussion on this concept, but this time I don't want to go to the much more detail. So for conversion the carbon monoxide adsorption in the molecular level, so there are two ways: weak back donation and semi-strong back donation of H plus. So the question is which mechanism has been proposed for potassium promoted ion catalyst in FTS. So everything, it's if it is difficult you also don't have to remember each and everything, and this kind of questions I think will be not asked into the final exam. So you have to just remember the concept in whole, so it will be helpful for you to understand the other things. So if you talk about the potassium promoted ion catalyst in FTS, so the answer is a semi-strong back donation. So okay, here you can see that if you talk about configuration, semi-strong back donation happening here. This is the metallic surface of the catalyst, so it always consists a metallic surface. At the same time, I think I didn't mention every part of this topic here, but it is mentioned in that if you talk about the ion catalyst, then it is here it is. The potassium promoted ion catalyst can also be included in its configuration in order to process this route for getting for giving the donation of H dissociation site. Then you can go for this semi-strong back donation, where you can use the potassium promoted ion catalyst. Last time we discussed, so we are not going to the whole detailed discussion. Then there was a Seton number, which is one important property of fuel property, which we can have to keep in mind when we want to understand what is the properties of fuel, why it will go through the combustion. So Seton number is an indicator of a diesel fuel as well as kerosene fuel we are using. We ignite it and burn it, and it will measure the knock tendency. Knock tendency is a property of a diesel fuel, or many kind of, even gasoline also has the same knock tendency. So what is a knock tendency? So how we can measure a knock tendency? So cetane is the normal cetane is the organic compound, and another is a heptamethylene nonane. We will use these two compound and we will make the mixtures, and we will understand what is the amount of knock tendency is there. So it is related to the ignition. So this overall serial number is related to ignition delay time, which is the time interval between the start of the injection and start of the combustion. So when you start injecting the fuel into your combustor or in engine, and it will start the combustion, so that is the ignition delay time. Whatever it is taking, it is known as a serial number, and it is providing the knock tendency. So whatever the delay time you are getting with this your particular fuel which you are using, and you have to compare it in the presence of normal cetane as well as heptamethyl nonane. And from this you can see that if your mixture is similar to the particular percentage of cetane, then you can see that this 30 cetane and rest is the heptamethyl nonane, 40 cetane, 50 cetane. So from this you can see that you can tell that your fuel has the cetane number of this much. And low cetane number is not useful because it has high delay time, and at the same time if you high cetane number, that is also useful. So this will because it's too high for the fuel may be ignited in short distance to inject nozzle and causes excessive heating of injector. The question asked is, as the cetane number increases, the ignition delay decreases obviously. But if you go to very high, then it's fast ignition, then it will be difficult for the engine to process the fuels. The adsorption is the process which we are using for the separation in the biodiesel process. So adsorption is in which atoms and molecule known as adsorbate form a substance, mostly liquid or gas, added to a solid surface called the adsorbent. Now adsorbents are natural synthetic material of amorphous and microcrystalline structures owning basic and acidic adsorption sites, where polar substances such as glycerol or methanol can be adsorbed and filtered out of the biodiesel. So for this adsorption we have to find this what is the adsorption loading, that's how much we are catalyst or what is adsorbate we are loading, or how much material we are taking, what is the selectivity of that particular adsorbate, adsorbent. Kinetics, compatibility, cost are the most important criteria that we need to adjust in adsorbent selection. Now question asks, cause the advantages of inorganic membranes or polymer membranes or biological applications are long-term durability. So inorganic membranes are long-term durability. So we have not visited all the concepts here. So it's very easy to understand. And the question asks, the most important criteria needs to be considered for adsorbent selection is there is selectivity is there, regenerability is there, adsorption, loading is there. So all of the above are the answers in this. Now we move to our current topic of week 8 discussion, which is nothing but the bio oil as well as biochar. So biochar is nothing but the type of charcoal which will be produced from the biomass, and the oil is produced from the biomass, which is known as a bio oil. So the biochar is mainly produced through a thermochemical conversion process such as a slow pyrolysis, fast pyrolysis, torrefaction and gasification. So there are many processes, but these four are the most important processes for producing the biochar. One is slow pyrolysis, fast pyrolysis, torrefaction and gasification. So we have to understand the various process parameters, and this process will be useful under their important you have to follow the important process parameter in order to complete this process. So this process is inversely change the physical state and chemical composition of the biomass into biochar in the absence or limitation of oxygen supply and the specific temperature and pressure. So this process inversely change the physical state. So they will change the physical state of the biomass, and it will convert by using the chemical composition also get changed biomass into biochar, and we have to provide according to the process requirement. We can provide the absence or limited oxygen amount in order at specific temperature and pressure. So biomass decomposition generally occurs during the primary decomposition to form solid char at 200 to 400 degrees centigrade. which is responsible for the largest degradation of the biomass. The secondary reactions proceed to take place within the solid matrix with further rising of the temperature. As you know that in our real gas, we see that bio and biochar are the two most valuable important products of the thermochemical conversion. So first we can see that at 200 to 400 degrees centigrade, primary decomposition of to form solid char will be taken place. So biomass get decomposed and it will convert into the biochar. And the secondary reaction process for after that, and it will be converted into the final bio oil. So biochar production method, if you go to in detail methods, and fast pyrolysis is there. These are also known as anhydrous method, where we are using the biomass which is made out of the corn, cereals, food pellets, palm oil, oilseed rape, and agricultural waste. So it will be give you product as a biochar, bio oil, as well as synthesis gas. If you talk about the slow pyrolysis, then the low temperature is a requirement. Which is 350 to 550 degrees centigrade, oxygen free. You don't need to use oxygen, and you can use the biomass feedstock, which consists tea waste, rice husk, biogen, energy residues, agriculture waste. And you will get the biochar acid gas at that. Yes, so pyrolysis, high temperature. The first one is the low temperature. So in high temperature, the temperature range is from 600 to 900 degrees centigrade, and it is also oxygen free. So you will not use the oxygen. It is an anaerobic kind of process, and we can use the feedstocks like municipal solid waste, rice straw, peanut shells, sodas, and hazelnut, and you will get activated biochar and synthetic gas out of it. Even then another process is the gasification, high temperature. In this, your oxygen is present over there. So what kind of feedstock we are using? Animal manure, bones, chicken waste, kitchen waste, or sewage sludge. You will get biochar, combustible ethane, as well as methane. So carbonization brown is 300 degrees centigrade. For if you want brown carbon, then the temperature range is around 300 degrees centigrade. For the black carbon, it's around 380 degrees centigrade. Woody waste, animal manure, and bones as a feedstock, and biochar is the product. Now, what is how the biochar is get produced? So biochar, first we are getting the biomass, and then we are drying it in the form of by using the drying operation. So we are providing heat, so that if you provide 100 degrees centigrade of heat, 30 degrees centigrade, so then you will maintain temperature more than 100 degrees centigrade. So liquid can convert into the vapor, and then it will be released from the raw material. 1 minute. The second step is the conditioning. In the conditioning, you are maintaining the temperature of 150 to 180 degrees centigrade, where you are not only removing the water vapor out of it, or H2 out of it, but you are also removing the CO2 along with the water. So it is known as a conditioning. And another operation is the torrefaction, where biomass starts to break down. Here the temperature is one step further, 180 degrees centigrade to 250 degrees centigrade. You are providing the heat, and then not only water vapor or CO2 you are getting the CO, CX, HY, OZ, and different kind of organic molecules. And then exothermic pyrolysis is there, where we are providing the temperature which is more than this 252. Here you can see that in this way the core of this biomass is getting shrink by time on the time interval. So after that, in exothermic pyrolysis, the temperature requirement is 250 to 400 degrees centigrade. So heat generated particles shrinks and cracks, and you will get that many products out of it: CO2, H2, COCH4, and CXSY, organic molecules. At the endothermic pyrolysis, heat required to raise temperature above 50 degrees centigrade. You get the same kind of molecules and CXHY hydrocarbon molecules out with it. So now, if you want to see, this is the same figure like professor. So in first, whatever the biomass which we have, as there is a fuel particle which has moisture and dry fuel. So we are going for the drying process, where you are reducing the moisture, and moisture is be removed in the form of water, and primary pyrolysis will be taken place. Afterwards, in primary pyrolysis, fragmentation and shrinkage is taking place, where dry fuel is converted into the tar. Water again, if some amount of water is still there, it is getting reduced. Permanent gas 1 and charcoal 1. So some permanent gases are always getting, and charcoal 1. out of this whatever the product you are getting, if you go for the secondary pyrolysis, then whatever the water you are getting, that still it's in the form of water. Whatever the tar you are getting, it is also converted into the water 2 and tar 2, and whatever permanent gas is there, that will be converted into permanent gas 2, and the char 1 is converted into char 2. But at the same time, if you want to see that pyrolysis includes very how many kind of reactions, so there are a number of reactions is taking place in pyrolysis. If you just want to know the for some example, then reforming, cracking, oxidation, water gasification, dehydration, polymerization, gasification are some of the examples for it. So if you want to see that how this virus is converted into biomass into the biochar, so this is a different kind of biochar if we can use it, and we have put it into the pyrolysis process. So before that we are doing the pre-treatment process, where we already discussed which kind of pre-treatments are there. So physical treatment, biological treatment, or chemical treatments are there. After that, whatever the we are going for the pyrolysis section, and then you will get the biochars. So biochar has various applications. If you want to see the biochar application, municipal application where removal of nitrogen, phosphorus is there. So it can be used in the storm water application where removal of metal, organic and biological pollutants. And it can go for the agricultural application where removal of heavy metals and pesticides from the soil. And in the some of the industry applications are the removal of heavy metals and dyes, organic pollutants. So whatever the get you will get, whatever the product you will get at the end, biochar we have many applications. But for biochar also can provide some physical and chemical treatment to get it. Now we will move forward. Then if we talk about the biochar market, so what is the actual market of this biochar technology and what is the future of this biochar? So as you can see, if we talk about the 2021 to 2031 data, so market by region of 2021 is mainly focuses from the from the point of view of Asia Pacific, in with this market will be increased, and followed by the North America, and then Europe and Latin America and Middle East. So this is how this market will grow. And what are the applications? If you talk about application, electric generation is a few in the very few technologies using for electricity generation. Agriculture is the bigger opportunity. Forestry and others are the another important key factors to use this biochar market. So what are the market findings? So key market findings. So one is the continuous feed pyrolyzers help to improve the energy efficiency in biochar use. Mixing biochar with animal manure helps to control the nutrients loss in soil. And every year it increasing. This market is up 15 to 35% at the CAGR. And if you talk about the 2031, then the market value is $6.37 billion. $1 billion is around 7.8 thousand crores, so 7,800 crore. So you can see that the technology, that the pyrolysis is the major chunk of the technology is using a pyrolysis technique. Another is a gasification. Some other techniques are there. So what are the factors which are affecting this biochar? Sorry, not biochar chemical properties. There are various factors are there. I'm not going into the much more details, otherwise the professor already visited many of the contents before. So if you that's why I don't want to repeat each in everything again and again. These are the important factors, so we need to take care of it. So one is first one is atomic ratio. So what is the atomic ratio? So we have to maintain the atomic ratios of carbon, hydrogens, and other oxygen, hydrogen and oxygen in particular biomass and biochar, as well as it will be useful to go for the next phase of bio oil production. So atomic ratio is the process of carbonization involves changes in chemical structure of the fuel, mostly by detachment of oxide group. So whenever we are going for the carbonization process to convert into the biochar or charcoal form, then it will some chemical structure detachment, because there are many functional groups that detachment will be take place, and mainly this detachment is taken place in the form of oxygen and hydrogen containing groups, which will result in a decrease in these ratios with carbon. So it will be explained by the Cleveland diagram. Another is elemental composition. So, what is the main goal of biochar production? Is the change in chemical. One main goal of biochar production is the change in chemical composition compared to the raw biomass. So, there will be change in the composition. So, most of all, the increase in the carbon content. Obviously, so biochar we are producing the char, so it will be increase in the carbon content. So this is due to the detachment of the functional group because we are removing the oxygen hydrogen out of it. So therefore an increase in reaction temperature leads to an increase in carbon content while resulting in lower content of hydrogen and oxygen. Energy content. As a result of the higher carbon content in the biochar, the energy content increases with temperature. So as soon as carbon content will increase in the biochar, energy content will also increases. The most significant increase in energy content takes place at temperature between 250 to 350 degrees centigrade. Within this range, only 100 degrees centigrade, the heating value is raised from the less than 20 megajoules per kilogram to 25 to 30 megajoules. So whatever the biochar you are getting, you need to understand, characterize it in the form of energy source. So if you can see that if you want to go for 253 degrees centigrade, the 20 megajoules per kilogram of energy will be increased up to 25 to 30 megajoules per kilogram. Then there is another important factor which is a fixed carbon volatile matter. So what is the amount of fixed carbon is there and what is the amount is there? What matter is present in your biomass? That will be important. So the carbon content that remains in the soil structure after the volatile compounds are given off is referred as a fixed carbon. So when you remove the volatile carbon, then it is what is the amount of carbon which it has. It is known as a fixed carbon. So some biochar applications, especially metallurgical, requires very high fixed carbon contents of almost more than 90% or even 95% in order to substitute for the fossil carbon carriers. The fixed carbon content of raw biomass is in the range of 100 to 30 degree, 100 to 30%, and there goes no significant change before the torrefaction range. Some important other factors for this biochar chemical properties. There are another factors for which are affecting to the biochar physical properties. So first one is the functionality. So the main process during carbonization is the thermal decomposition of the biomass structure, resulting in the detachment of functional groups and the release of oxygen and hydrogen. This is the biochar with low hydrogen and carbon ratio, so that correspond to a higher degree of carbonization content less functional groups and more atomic structures with low temperature chars. So as content composition, many parameters, for example, elemental composition of fixed carbon content are typically given on dry and S-free basis. Okay. So we have to find that what is the S content is there. We have to remove it. The water is completely given up during the pyrolysis, and however the S will be largely immense in the soil product. It is important to know the S content of the biochar because the amount or type of inorganics can determine possible application. High S content may also inhibit the use in high grade industry application. The increase in S content may intensify use related to problems during the thermochemical conversion of biomass. Now, if we talk about the physical properties which are affecting the biochar production, there are only 2-3 properties are there. We need to focus on. One is the density and porosity. So the most significant reduction in bulk density is achieved by drying. So we have to reduce the density, and then it will be taken by achieved with using the drying process. So which may be separate step or integral part of the pyrolysis. We can combine drying with the pyrolysis also, or we can do it separate also. So reducing the bulk density of green wood from 700 kg per meter cube, so 700 kg per meter cube to 400 kg per meter cube. This is the power of drying. तो सबसे को कार्बन process temperature about 300 degrees. After this 300 degrees, if above 300 degrees, if you do the carbonization process, then it reduce the bulk density further to 300 to 330 kg per meter cube. So surface area, the porosity changes. Now another is the surface area. So the depending on the porosity, so it has a the different values of volatile gases which will be escaping out of it during the carbonization process. The total surface area of the biomass is much more important. So the surface area is connected to a number of other biochar properties. For example, cation exchange capacity or water holding capacity, therefore prerequisite a number of biochar applications. So it will be useful to direct further application of this biochar. So if you have low surface area, then this may be the large surface area connected to a number of other biochar properties. And this will be the probable use case. While the large surface area is characteristic biochar for pyrolysis, the residues and anthropogenic have a very low surface area. The surface area is determined by BT analysis. Now we are before going towards the reactors for the biochar production. Just give me 1 minute, as my health is not good. I have to take medicine. Okay. Sorry, as no one is attending this course, I thought that I will take medicine in between, so it will give me some relief. Okay, so reactors for biochar production. So after that, I will not cover each and every topic of this uh, particular week discussion, but some important topic we need to cover. In that, important topic is the reactors. So there are which kind of reactors which we are using for the biochar production. So mostly the focus is on the slow pyrolysis. So in that biochar yield is between the 25 to 30%, and during the slow pyrolysis the recent time of the feedstock is longer. Feedstock is longer. So why it is known as slow pyrolysis? Means it is a process taking up slowly, and we are providing the much more time, the sense time in for the biomass to stay into the reactor, and the temperature are lower than the 700 degrees centigrade. So this allow all the volatile compounds to escape, leaving a Charlie solid behind. And in this, there are two mainly different kind of processes or reactors which we have, production processes in which different kind of reactor configuration we are using. One is a pyrolytic gasification. So it is an example of the indirectly heated process which utilizes an external vessel to burn portion of the fuel and uses the heat to pyrolyze the biomass producing medium energy gas with significant fraction of tars. So here in this process you will get a significant fraction of tars in this process, and you will burn the fuel and use the heat to pyrolyze the biomass. So if you recall, this already discussed in gasification. So design is great prospect of modification to produce biochar because the moment of the ignition front allows the char behind, leaves the char behind. Sorry. Orthothermal reactors provide the necessary heat of reaction by means of a partial oxidation of the biomass within the reactor. The heat produced is sufficient to drive the endothermic reactions within the reactor to produce biochar, biooil, and synthetic gases. Now, if we talk about the this gasification process is always coming in between. So, what are the for processing gasification? We already covered it in the chapter of gasification. So first it is start with a drying process where we are providing the heat to biomass and remove the water vapor out of it. And another is the next step is it is all these processes are taken place inside the one pyrolysis reactor only. In the second, if we talk about this, is then charcoal and tar will be removed. Why? How it is here? It is known as a pyrolysis reactor, where you provide the heat without air or anaerobic without in the presence of air, so that will the biomass will be converted to a charcoal and tar. And the third one is the combustion process, where you provide a limited or excess amount of oxygen and air depending on your process requirement, and you will get the charcoal or tar gas. And in the gas phase you will get the water vapor as well as carbon dioxide. And the last step is the reduction. where you use H2 and CO2 in the hot charcoal, and then it will convert into CO&H2, which is known as a water gas shift reaction, which is very important reaction, water gas shift reaction, which will be useful to form the to produce hydrogen also. So this is how this one cooking batch cookstop of biochar production is taking place. So you are providing it's a whole combustion chamber. Gas will be collected out at the end. First and two counters are there. We have to feed the material in it, and air will be inlet from the up and down, and the cooking batch will be there. We'll go into the much more detail of this particular pyrolytic gasification equipment. So as you can see, this is the process which we are discussing currently. So in this, first we convert the lignocellulosic biomass or any kind of biomass into the different kind of um, particle sizes on chips or in the form of the pellets. So combustion chamber design is in the form of CG1 and CG2 are the patented technology, and combustion and gasification air ratio we are maintaining by using this air to gasification air combustion air versus gasification air controller. And here you can see there are many number of processes are going there. So if you talk about that energy performance after it, whatever you are getting as a product, which is have the efficiency of 25 to 21%, and there are different parameters. And what is the environmental performance? It is can produce a CO 2.78 gram per megajoule, and total particulate matter are 74.11 milligram per megajoule. So the main thing is I want to tell you that there are number of reactions is taking place in the pyrolytic gasification. As you can see, each and every step has a different temperature value, different heating value inside this, and depending on that and what are the availability of the different raw materials, it will convert it going to many reactions. So as you can see, number of reactors in reduction, oxidation, reaction, pyrolysis, section, drying, raw biomass we added, then it will go to drying, pyrolysis, oxidation, reduction, and then converting biochar, and you will also get the producer gas combustion will be taken place, and that will be convert the steam in the one way, or in the other way, another, and you will also get some pollutants in it, so which are nothing but the COMP, whatever, CO2 others. So gasification I will provide further down. Now there are two kind of main important reactors which are taken which is useful. There are various ways to conduct out this gasification pyrolytic gasification process. But one important the technology is auger reactor. In auger reactor, as you can see, this is a hopper where you put your biomass, then it is feed by using the feeding hopper to the screw, and screw is at this may you can have better control on your feed into the final reaction. Here the reaction is taking place in the bigger screw where you can control the speed. So depending on your requirement, you can go for the slow pyrolysis by controlling the slower speed. If you go for the high rapid speed, and the fast pyrolysis, conventional pyrolysis is also there. So here inside also the reaction zones are primary reactions, secondary reactions, and heating zones are there, which has a less atmosphere inside it, which is nothing but absence of oxygen is there, and you will get the sensible heat as well as reaction heat out of it, and then primary and secondary reactions are taking place, and you will get the solid fraction out of it, and whatever the liquid is going there, it will be going to the heat fraction, and then you will get the liquid fraction out of it. So solid fraction, whatever you are getting, it is a biochar. Now if you go to the detail of this process, and biomass and heat and are sometimes combined together, so it will heat and will provide the what requirement fulfill the requirement of the heat, and then it will be fed into the auger reactor, and then you can see that whatever the vapor gas and charcoal you are getting, other than charcoal and sand you are getting, where you are separating the sand, and you are again recycled back into the heated sand, heated it and recycled back into the process. So here you can see that sludge of biomass is coming down, screw rotating in this direction, and heated zone is particular interaction, solid direction movement is going to happen this time, and at the bottom you will get the charcoal, and the top you will get the various gases. Now it is mostly we discuss about the biochar. Now we are moving to the another important part of this lecture, which is a topic which is a bio oil. So we have seen that there are various types of pyrolysis are taking place, slow pyrolysis by and some kind of different kind of pyrolysis, medium scale pyrolysis, and very fast pyrolysis. So any of these fast pyrolysis is taking place in the presence of high temperature, so in which biomass is rapidly heated in absence of oxygen. So it will result in sometimes mostly vapors and aerosols and some charcoals you will get at the end. So what are the aerosol you will get in that out of you can convert it into the liquid production, and liquid production actually requires very low vapor resistance time. So whatever the vapors will be there inside the reactor, which will be having the low resistance time, so it has minimized the secondary reactions of typically 1 second. So the reaction is taking place within a second, and acceptable yields can be obtained at resistance times up to 5 seconds if the vapor temperature is kept below 400 degrees centigrade. So after cooling and condensation, dark brown mobile liquid is formed, which has a heating value. So if you talk about the whole process after this experiment is taken place and within the below 5 seconds at 400 degrees centigrade, so you will cool and condense the process. In that you are getting the mobile liquid, which is in the color of dark brown, which has a heating below about half of that of the conventional fuel oil. Both resistance time and temperature control is important to freeze the intermediates of most chemical interest in conjunction with moderate gas and vapor phase temperature 400 to 500 degrees centigrade before recovery of the product to maximize organic liquid yields. Now this is all about the what is about how it will be used produced. Mainly it is produced by using the but the fast pyrolysis only. Then another is how it will be produced. So for the bio production, the most important pyrolysis is the fast pyrolysis. This is the process which we are using. So it requires very high heating rate as well as heat transfer rates, which is requires a finely ground biomass feed. So for that, whatever biomass which have it in the form of the finely ground, which is in the form of the powder. So carefully control pyrolysis and temperature above 500 degrees centigrade in the vapor phase. So whatever the pyrolysis is taking place at the 500 degrees centigrade, we have to maintain some control carefully and monitoring it diligently, and in which you will get the short vapor resistance time. Vapor resistance time will be very less than 2 seconds, and rapid cooling of the pyrolysis vapors to give the bio oil products. Now the main product of bio oil is a miscible mixture of polar organics. So actually bio oil is nothing but it is a mixture of polar organics. This is what exactly I was mentioning just one slide before. So it is already mentioned by the professor, and it is about 75 to 80% weight, and rest is water. So 75-80% is nothing but the polar organics. Polar organics is the, suppose you can see the alcohol and all, which has a polarity in the organic acid is also there. So that kind of organics, and other than that 20-25% is water. So in that we are providing the very short resistance time, so complete depolymerization of the lignin is happening due to bond cleavage and the interaction of lignin molecule resulting in less homogeneous liquid product. While longer resistance, if we provide longer resistance time, then it will be converted into go for the secondary cracking process and convert into the primary products with reduce their yield, and it will also affect the properties of the bio oil, as well as the bio oil if it has many problems when we are using it into the commercial purposes. So we have to think about how we can utilize the bio oil. So there are mainly two processes which are importantly useful, and this has a very well developed and mature technology is there, and there are many other processes which are in the development phase, and research is taking place in on particular processes. So if we talk about the bioproduction with the circulating fluidized bed reactor, then the biomass is using into the control feed into the pyrolyzer. This is a particular reactor which we are using, but this is in the form of fluidized bed. So whatever gas which we recycle or additional fresh gas, we are adding it from down, and we are also using the hot sand as providing to the heating medium. Then what are the biomass is there, it can be in the form of fluidization. So in the this is that's why fluidized bed reactor. So then this fluidization have occur here in the pyrolyzer. Then what are the low density product is that it will come to the cyclone separator, and from the cyclone separator you will get the sand and charcoal at the bottom product, and for in that you will go for the two set of cyclone separator, and one you can remove the sand and char, and then when you have mix of second char, and if you put it on second cyclone separator you will get the charcoal as is the down as you are providing, and hot sand whatever you are separating out, it will be fed back to the main pyrolyzer, and flue gas will be removed, and the cyclone separator of product of first cyclone separator will go into the cooling quench or quench cooler or absorption, and in which you are getting the bio production, and here we are also using electrostatic precipitator for getting the higher conversion, and from this your byproducts are the gas for recycle export of flare, and then what are the gas is there which can be recycled and can take to recycle gas heater, and it can use it in the oxidizers. Now another important reactor is a rotating cone reactor. In the rotating cone reactor, as you can see, so this is a cone is there, and it is continuously rotating, and if you can see it soda feed or any kind of biomass feed is possible, we can use it, and we also can we have to use sand, and sand will be heated in it. So whatever the heated sand will feeding into it, it will be give you the uh, this particular temperature heat energy to the biomass, and reaction process taking place here. So it is actually looks like this. So biomass will be added into it, hot sand will be added into it, and the reaction is taking place. So out of it you will get the solid product which consists of sand and charcoal. So it will be fed into the combustor. So you provide the air into it, and we will remove the flue gas, and whatever the sand is there you can recycle back into it, and flue gas and ash get removed, and if your vapors will be going to the again separator, in which condenser gas will be removed from the liquid, and liquid is nothing but the bio oil. So you can put it into the store. Bio storage will be there, and this is the process of the rotating cone reactor. Another first process is the first process fluidized bed reactor, and this is the rotating cone reactor. No, give me 2 minutes. We'll move to the another topic. Actually, I didn't cover some of the topic in between, but we can move to the fuel characterization techniques. So whatever the biochar or bio oil you are getting, so we have to characterize it. So for that bio oil, if you can see that most important parameters are the acid values. So what are the fatty acid chains are there? We can use for the acid value is from by using the titration. We already discussed about this in the last chapter. Then heating value are higher or lower. For getting it to heating value, we can go for the this table is little bit different from the professor, so you can get to the other you can also see that how it can be represented the method. It is from the different paper, so it can be used that for finding the heating value you can use the calorimeter. So this is a kind of calorimeter which is produced from the chimney, which are the method, and these terms are the if you want to understand in more detail, you can just write this standard into Google. You will get the whole procedure, how this process taking place, and which kind of instrument we have to use, equipment we have to use for converting it. Then is the density. How can we measure density? By using the intent power place equipment. Kinematic viscosity can be processed by the viscosity meter, viscometer, which name is given Lewis, and from the intent part, and then these are the standard. Oxidation stability can be taken by the metro home biodiesel cement and cement. And then glycerin monoditriglyceride. How can we find that what is the amount of glycerin is there, monoditriglyceride is there in our biomass? So it will in the weight percent, or we can go for the GC, gas chromatograph, in the form of FID. So flame in detector, flame ignition detector. So iodine value can be converted from the titration. Moisture content will take percentage for the Carl Fisher titration, and meter Toledo kind of thing, where your moisture content will be measured. So we will discuss into the much more detail in the next slide. Meta-ester conversion will be done from the gas chromatography system, which is coming from mass spectrometer system from the children. This particular paper used this technology, but it will in general these kind of instruments are used. Another is a cold filter plugging point, where this is the instrument flash point will be taken place by the petrol test. C10 number can be Setox, octane number is the instrument, and CHNS number is using the CHNS analyzer. CHNS is nothing but carbon, hydrogen, nitrogen, sulfur element is presence of this four element in the form of mass per weight percent. You will get using the Pulkin-Elmer series. CHNS instrument is known as a CHNS only. So there we already in detail professor discussed many different characterization techniques which we just saw, which are the techniques are there, what is the equipment we can use, what is the methodology, what is the standard is there. But we will not go into the much more detail. But the one important characteristic is characterization is a new thing for you. So you can see that it's the water content determination. So we can determine the water content. So water content determination of biodiesel, it will play a significant role in the quality of the feedstock and the end product. So we have to consider the biodiesel hydrophobic, but it has 15 ppm. So 1500 milligram per liter water dissolved into it, milligram per liter. And it's also much excluding the suspended water tablets. Okay, so you can see that although it is everything is hydrophobic, it is organic in it, but it has dissolved water in it. And there are several methods of for this dissemination of water is required, is available in the world, which is nothing which is like one is the loss on drying. We'll dry it, and how much moisture we're getting lost, how much mass getting loose we can convert into, but that is not that much accurate. Then there is a reaction with the calcium hydride. So calcium hydride is highly reacted with the water, and then you can see that Fisher titration, which is the most adapted one. Then the Fourier transform infrared or Raman spectroscopy and dielectric measurements. So Fourier transform infrared means FTIR process, and Raman spectroscopy dielectric measurement you can take. So now all this can be give you the amount of, not exactly quantitative amount, but this Raman and FTI give you the qualitative amount of qualitative categories, where you can understand that how much moisture content is present, moisture content is present or not. Among all this, the KFT or Carl Fisher titration is certainly the method of choice, because it will be used by many of the industrial standards as well as research standard. It is be helpful. So you can see that we can find the trace amounts of emulsified of water, and it to be accurately determined in the very reasonable time or very less time. So that's why Cape titration is important. And if we talk about the Cape titration, which is it is a based on Bunsen reaction between the iodine and sulfur dioxide. So it is a reaction between iodine and sulfur dioxide. Here you can see. And the primary alcohol can be used as a solvent, and the base for the bubbling agent, the alcohol. So you have to make the buffer solution. You have to make every time you have to use this buffer solution before the experiment. So it will be useful for the correct. So the alcohol reacts with the sulfur dioxide, as you can see, and base 2 and also base to form an intermediate alkyl sulfide salt, which is then oxidized by the iodine to an alkyl sulfide salt, like a sulfate salt. So this is a reaction which is taking place in the Carl Fisher titration. So it's important, you can remember for this. Another is a technology after this is bio upgradation technology. So whatever bio which we are getting, this is not directly in the form of application, or we can utilize in the various application. We have to provide into some kind of upgradation. So in this, there are number of objectives for upgrading, of which the first out of which the first objective is the course of the improvement of the bio quality to overcome reduce one or more of the fuel quality deficiencies. So we have to overcome, reduce, or another deficiencies are there in the fuel quality, we have to improve it. The second is the production of chemicals. You can produce a chemical after upgradation, and if you remove the oxygen, then you can produce hydrocarbon biofuels also. So we have to be much selective in order to go for the upgradation. What is your purpose? One, you can increase the quality of bio, another is you can go produce the various chemicals. The most important properties that inhibit the widespread use of bio oil are: the first is the phase separation. So phase separation from use of wet feedstock and secondary cracking of vapors leading to high water content in the liquid product. So you have to you have to check that how can we separate this phase separator by using the wet feedstock. So phase separation cannot be reversed except through a relatively high addition of co-solvents such as the ethanol. So this is a widespread property which we are using of phase separation for the upgradation. So another is incompatibility and immiscibility with conventional fuel. This is an important aspect for which we have to go for the upgradation. So incompatibility and immiscibility with conventional fuel from the high congestion oxygen content of the bio has very high oxygen content, so we have to remove the oxygen. Then you can easily immiscible or comparable with the conventional. And then cannot be do, the problem is that you cannot be blend with the petrol fuels. So for blending into petrol fuels, you have to reduce oxygen content. And then high solids content, bio has a high solid content affect the catalyst and utilized in the engine and burners. So engine also has one catalyst, or many kind of catalysts we are using in the engine also, which will be degraded by using the high solid content. So high viscosity that hinders the pumping and combustion, and which cannot be ready to be controlled by raising temperature as for heavy fossil fuels due to temperature sensitivity. So bio oil has a high viscosity, so it will be not easy to pump it in the combustion chamber, and it is hinders the pumping, and it will raising the temperature, and the temperature sensitivity will be there. Now you can see that bio upgradation technology in this. So there are overview of the fast pyrolysis upgrading method. There are direct route as well as indirect route. So indirect route biomass is directly go for the fast pyrolysis gasification. From its synthesis or conversion of isotope, so you will get the alcohol out of it. If you go for the so this is the indirect route. If you go for the direct route, then the cracking, refining, and you will get the hydrocarbons. You will get the chemicals after modify with different chemicals, including esters. You will blend it into the fuels. You will modify the example esters. You will get the chemicals. Liquid and biofuels is there. So in the fast processes, hydro processes are there. We go for the refining, and we got to the essential design gasoline. This is how we can upgrade our biomass. For using the fast process, whatever the product is there, we can upgrade it. So if you go for the geolite cracking, then the biomass is go for the fast pyrolysis. Then it is also indicated a catalytic fast pyrolysis, and you will get the upgraded product directly. Otherwise, from this fast pyrolysis, you will get the liquid and vapor. Using the catalyst, you will get the upgraded product. One kind of a vapor in the liquid, and the volatilization will be there. Different kind of catalyst will be there. Like a conventional upgrade product. Now, if we talk about the different technologies where for upgradation, then there is a technology for the fast hydropyrolysis reactor. In the fast hydropyrolysis reactor, there are different four kind of configurations are there. In the first configurations, so biomass will be fed here, hydrogen can be fed from down, and in that you will see the inert particles are there. They are actually not the catalysts, but they are the inert particles or bad materials are there, and out of which we will get it oxygenated where the vitality is at the, from the feed. Similarly, you can use the same process, but instead of this inert particle, you will use the catalytic particle, and the catalytic particle will be reacted. So catalytic fast hydropyrolysis reactor is coming to picture, So you will get the reactions taking place inside, and you will get the hydrocarbons products out of it. It's not oxygen and water, it has hydrocarbon product. The same, you again use the inert particles, but it is a fast hydrolysis reactor. Biomass feed is there, and you are using your hydrotreating with catalyst. Here you are providing the catalyst in the hydrotreatment and as a separate unit. So whatever the feed biomass is there, it will be in the presence of, we talk about the first inert particles or bead are there. Then oxygen and water, say that the hydrotreating, they are using hydrotreating unit with catalyst, you will get the hydrocarbons out of it. So it is your desired product. This is a direct step. We have this here using the separator between or hydrotreating unit. You can use another side. It's not separator, it's a hydrotreating unit where you treat your biomass products out of it, out of the fast pyrolysis sector. So here catalytic fast pyrolysis, fast hydropyrolysis sector. This is all about hydropyrolysis, not only pyrolysis. When you are provided H2 feed and then you have the catalytic particles, then whatever the hydrocarbons you are getting, it will be again go for the hydrotreating with the catalyst, and then you will get the hydrocarbon. So similarly, if you have pyrolysis, then whatever biomass will come to here from the dryer, and whatever dry feed it will go to gasification zone, pyrolysis zone, you will get various kind of gases out of it. So steam is provided from the down, and product will go into the cyclone separator, and from the cyclone separator it will be fed into the combustion chapter, combustion chamber or combustor. By using the temperature is maintained by using the sand. So whatever the sand and char is there, it will be directly going to that. And in another you will get the sand from out of it. It will be again go for the dry sand will be dried and again and back to here. So the cyclone separation is taking place from the way it will be going to the combustor. You will get the sand, and sand will be going to down again. So what are the second when you go temperature adjustment, catalytic hydro deoxygenation, and it will go into the last part. It's a condensation gas liquid separator where you are getting the biofuel, bioproducts, and gas for fluidization and drying. Biofuel is I remember. Now, if we talk about the characterization techniques of the biochar, so this is also important. Characterization of biochar, there are different kind of characterization processes are available. One is a chemical characterization, another physical characterization. If we talk about the chemical characterization, then you have to go for the what are the various chemical properties of this biochar and what is the value of this. So one is the pH measurement, we can measure the pH. Another is the elemental analysis. Another is the BET. BET surface area. It is very useful for finding the surface area with the help of the mercury and different chemicals. So then another is a Bohem titration process, FTIR, Fourier transform infrared spectroscopy, or Fourier transform infrared spectroscopy, and that you will find different kind of chemical additives available inside it. And gas chromatography is obviously there. So various kind of gases will be generated from this biomass conversion process. You will go to understand about this zeta potential of the biochar colloid. So whatever the zeta potential is, the potential is will be give you the your final product will have the how much electronegativity is with the present in it, and either it is a positive or negative charge, or it is a neutral in sense. Then NMR process. NMR process is very well known for finding the characterization of the different functional group inside your product. And if you talk about the physical characterization, then there's scanning electron microscope and tunneling electron microscope. That will give you you will get the photos, pictures, taking pictures with using the electron microscope. Electron beams will be there, and then you will see that morphology of the surface by using this. Then in tunneling electron microscope, you will see through the product, and you will get to know what are the morphology inside the product. Is the particle size distribution will be you will be measure what are the ppm average ppm size on ppm nanometer micron size of your product. X-ray absorption near its structure, so X-ray will be there. Then moisture content is there, as content you can find bulk density, pore volume is there. If it's again percentage the different way the characteristics are. If you talk about physiochemical, then physical pH, CEC, and electrical conductivity. If you talk about chemical, then surface area, particle size, distribution, bulk density, and pore size. cover the surface process, then the SCM morphology. FTI and Raman will give the functional groups, and SCM ADX will give the surface elements, ADX. So it is known as ADX also. We talk about the structural molecule, then the TGA thermal analysis, the TEM and XRD, the structure elements are the NM and Raman aromaticity. Now this is the overall process for the biochar production, and if you can see that the biomass feedstock agriculture waste, bioenergy, crops, forest, residue, organic waste, sewage, sludge, other waste material will be there. It will be go through the pyrolysis process, where so pyrolysis, past pyrolysis, intermediate pyrolysis, gasification, hydrothermal carbonization, flash carbonization process are there. And before that, your biomass will go into the pre-treatment of washing and drying, and here you are maintaining the process condition. And for the production in the pyrolysis process, the pyrolytic temperature, heating rate, time, pressure, surrounding it up cooling rate will be there. After we will get the biomass biochar production. Biochar products will be converted into solid biochar, liquid bio oil, or gas, synthetic gas. These are three phases of product you will get out of this biochar. In the solid you will get the biochar, in the liquid you get the bio oil, and synthetic gas will be get the gas. And for before that you will go for the post treatment if necessary, if required. So thermochemical activation, separation, drying will be take place. You'll get the final products, and final products as a characterization will be take place, and then you go for the application and mitigation of environmental climate change, waste management, energy production, and soil improvement and other emerging applications. Now today as my I have fever, so we'll not discuss much more, and as at the same time no one is available into this meeting, so that's why we are not stretching this lecture anymore, and we cover the check the discussion of biodiesel and all the 7 questions of it. And at the same time, the 8 chapter discussion in brief, which is all about the bio oil, biochar and bio oil. So then I just want to quote the Jagdish Chandra Bose, famous scientist from India. He mentioned once, if there was been any success in my life, that was built on the unshakable foundation of failure. So you have to be face the failures in order to find the success. So this is my, again I am giving my mail ID here. So if you want to know about anything in this course, or if you want any query or doubt, you can reach out to me by using this mail ID. I already give you my WhatsApp number also. Actually you joined right now, but today my health is not good, so I covered all the topics, and I will go through slide by slide once. I will not go to discussion, but I already covered the topics today. So I didn't cover for the whole 2 hours. So we discussed about week 7 discussion, which is all about the biodiesel. So this last time we discussed. So on this discuss what is the composition of the various vegetable oil, and then what are the important factors to find the saturation and unsaturation molecular weight by using saponification value and iodine value, and we solve the assignment question based on it. So this is the composition of vegetable oil, the famous transesterification process, which we went through the much more detail in the last week discussion, and this is the how process it take place, and the some questions based on the soybean oils, and which is the what are the major fatty acids in the soybean oil, and this all is there in the write-up of the professor. Fatty acid is represented by C18 and has one. So what is that? So C18 carbon atoms and one double bond is there. C18 2, then 2 double bonds are there. So canola oil is there. So it has the composition of the different oil as well as the erucic oil. So erucic acid. So what is the erucic acid? How much acid content should be allowed? It's around 5%. And there is a whole sector of understanding from the not from the vegetable, but we'll go for the transesterification process from the algae, and this is how it is taking place. And the questions are in from this because algae has lipids in it, so there was a question the lipids are soluble in which form. It is insoluble in non-polar solvents, it's in organic solvents, and soluble in not soluble in polar solvents. So syngas biorefinery, with last lecture we discussed. Transfer esterification reaction we also discussed, and questions asked on this, which kind of alkaline catalyst which we needed. So mainly we are providing the base environment. So uh, strong base like sodium hydroxide and calcium hydroxide, we can use it. Then tuning will be there. There were question out of it, we covered it. And cetane number, what is cetane number? It is a mixture of normal cetane and heptamethyl and non, and the providing the making the mixture which is giving the same ignition delay of our required fuel. The question is asked was that if cetane number increases, then ignition delay will be decreases. It will go for the fast ignition. Then adsorption is process there. So question asked about the membrane and adsorption, which were covered. And today's discussion on bio-oil and biochar. So we discussed what is a biochar, what convert into biomass, and these are the various process to make the biochar production. First is a pyrolysis, slow pyrolysis, and from there low temperature, high temperature gasification and carbonation. Another then, which are the steps of biochar, and we cover the which kind of process are involved mainly in the pyrolysis process. So this is the factors we discussed today, which are the affecting physical factors, and which are affecting the chemical properties as well as physical properties. What are the reactors which can use in the gasification? We can use various reactors as well as pyrolytic gasification and agar reactor we discussed. Bio oil, I didn't went through the each and every topic of the professor, as due to time limit and we can't cover everything, but what are the important topic we solve the assignment problem we covered. Then we switch to the bio oils, which is nothing but the same pyrolysis process we are using, but instead of slow, it is a fast pyrolysis process. So in the absence of oxygen, the vapor will be converted to the liquid. It will go with the bio oil production. And we will discuss about the fluidized baked reactor as well as rotating cone reactor, which are the characterization techniques which we are using with generally basic fuels are in the normal fuel. And there was a various techniques we can use, but the important is the water content determination, which is Carl Fisher translation, because if bio oil has a water content, then it is a detrimental to the engine and the whole combustion process. Then how we can upgrade this bio oil? So we see through the various process for the upgradation, and what are the characterization techniques we have seen, all the techniques discuss then we discuss briefly, and professor discuss in much more detail. You can watch the videos and text transcripts, you can read it. And art and what is the process flow of all this process. Then you have the various feedstocks, you are providing the pre-treatment, and you go for the pyrolysis process, which will give you the production of biochar, where you maintain the process condition. The pyrolysis process, which is different combination, you can see over here. From this product, before product, you will give the post treatment if it is required, thermal separation on dyeing, and the product you will get, will go for a characterization, and various application of these products are there. And at the end, this is my mail id, you can contact me for further understanding. uh, so pardon me, I can't able to take a lecture mode. It's already 1 hour and 25 minutes. So I already record this lecture, so you can go through the YouTube and you can see the recording. So meantime, the ma'am stop sharing it. And if you have any particular question, you can ask me, or otherwise I am leaving this meeting currently, so I will upload the YouTube video by tonight, and you will get to know. If you have a question, you can ask me. Or else I will leave the today's meeting. So if you have any questions, you can ask me. Do you have any question? Okay, if you don't have any questions, so I will close this meeting. And we if you want to know anything else, so I already uploaded all the video, but if you want to go into much more detail, if you have any particular query, then please contact me. And I'm dropping my WhatsApp number over here if you want to contact anytime. So due to my health, I need to stop today. So okay, have a good night. Take care. I am closing this meeting. I'm asking the last time. Do you have any question? You can ask. Otherwise, you can also leave.